Welcome to the demonstration of SANSlide. SANSlide is a new and innovative technology that solves the problem of transporting big data over long distances. On your screen is the management console of the SANSlide Data Transport Acceleration system. If we switch to our demonstration control screen, you can see at the bottom the architecture of the demonstration environment. On the left is a data source. On the right is the target where data will be captured. In the center is Wannulator, an open-source wide-area network emulator commonly used by network and telecommunications engineers to simulate real-world wide-area network conditions. The box labeled network conditions is where we change the milliseconds of delay, also known as latency, which is the root cause of slow throughput over wide-area networks. The SANSlide devices, shown here and here, make this remarkable improvement possible. They can be activated by turning on their patented artificial intelligence using the button near the top of the screen. We begin the data transfer, pushing data from left to right. This is a single data stream, which is the most difficult to optimize over long distances. By returning to the management console and clicking on Transfer Statistics, we can look under the covers at the data transfer process. Note that the data transfer has begun. And throughput, the transmit rate, is 99 megabytes per second. This is typical in a local area network scenario, across the wire within the office or data center. Now, we'll increase the latency to 30 milliseconds. This is typical of a well-optimized data circuit running about halfway across the continental United States. As you can see, this causes performance to dramatically drop, netting a transfer rate of about 3 megabytes per second. Next, we activate the SANSlide devices by clicking the Turn AI On button. This turns on the SANSlide's patented artificial intelligence, which creates multiple parallel threads that optimize and maximize throughput. Transfer speed begins to climb as the SANSlides communicate with each other and fill the pipe, a remarkable achievement when transferring data halfway across North America. Shorter distances can have similar latency if the data circuits are not well configured or if telecommunications quality is poor. Throughput will continue to rise, and please note on the left the axis, which is dynamic and will change according to the peak level shown on the screen. The throughput levels out at about 118 megabytes per second, almost 20% faster than local network speed with no latency. Data networks, however, are dynamic and constantly changing. So to illustrate this, we change the latency to 60 milliseconds. As you can see, there is a momentary dip as the SANSlides use the self-configuring and self-managing capability inherent in the devices to adjust to this change. Then the throughput jumps right back up to the 118 megabytes per second we saw previously. This automatic configuration allows data throughput to be maintained despite ever-changing network conditions. In short, big data can now be moved across long distances in much shorter time than was previously thought possible.